Year 5, bit of a different video today because I'm stuck at home because of the snow. Hello tractors and ravens, I thought why not use the snow to help us with some of our fractions today. And I've made 18 snowballs here, and I'm asking you, if I put my snowballs into piles of 4, can you tell me how many snowballs I've got as a mixed number? Pause the video now and have a go at working it out, and then check that back in for the answer. Right, so piles of 4 tells me that we're working with quarters, so I'm going to make one pile of 4 here, and I've got another group or pile of 4, another group of 4, and you should see that I've got 1, 2, 3, 4 complete groups of 4, so that's my 4 holes, and I've got 2 left over. So how could we say that as a mixed number? And you should all be saying to me it's 4 and 2 quarters, or we could say 4 and a half. Well done. Now, what if I throw 3 of my snowballs? What's my mixed number going to be then, or how many snowballs will I have left then? Pause the video and work it out. Okay, so I'm throwing 3 of my 18 or my 4.5 groups of snowballs. So there's my 1, throw it, and my 2 and 3. And what does that leave us with? So I've got 1, 2, 3 holes with 4 snowballs and 3 left in my last one. So I've got 3 and 3 quarters. Okay, I've got 15 snowballs left. How many will I have left if I throw 2/3 of my snowballs? So what you need to think is I've got 15, you need to divide it by 3 to work out 1/3. So 15 divided by 3 is 5, but I said 2/3. So if 1/3 is 5, how many is going to be 2/3? And that's right, it is 10. So that means I'm only going to have 5 snowballs left over. Okay, and it's a bit cold. I think it's time to go in. Ah, that's better. Back in the warm now. Okay, Year 5, you've got a code breaking mission to do today, all about adding and subtracting fractions. But there might be some in there with some mixed numbers. So we're going to do a few examples together before you go and have a go at the code breaker. So if you had the question, 1 whole take away 3/8, what do you think you need to do or work out first to help you? Because you've got 2 different types of fractions. We've got a whole and we've got a non-unit fraction. So I would put this 1 whole into 8ths or into a non-unit fraction to help us. So who can tell me how many 8ths are going to be in my 1 whole? And that's right, it's going to be 8/8. So if we cross out our whole and put 8/8, because they are equivalent, they mean the same. Now what we're doing is 8/8 take away 3/8. And we know when the denominators are the same that we can just ignore them and subtract the numerators like we would normally. So 8 take away 3, 7, 6, 5. And my answer is going to be 5/8. Okay, nice and easy when you've got a mixture of whole numbers or mixed numbers in the fraction. Try and put them into the same type of fraction to help you. Right, revising what we did yesterday and on Friday. What if I had 2/5 add 1/3? Just got rid of that. Can I add 5ths and 3rds together as they are? No, I can't, because I've got apples and oranges and I'm trying to add them up and they're a different fruit because they've got different denominators. So what do we need to do when we have numbers with different denominators? What do we need to do when we've got fractions with different denominators? We need to find the lowest common multiple of the denominators. So I've got 5 and 3. What number is the lowest common multiple of 5 and 3? The 5 times tables tells me it's got to end in a 0 or a 5. So is 5 in the 3 times tables? No. 10? No. 15? 3 times 5 is 15. So 15 is going to be our common multiple. So we need to put both of these fractions into 15ths before we can do anything with them. So 5 times what is 15? And that is 3. Therefore we need to do 2 times 3. 2 times 3 is 6. So 2/5 is equivalent to 6/15. And then for my third, 3 times what is 15? And we know that is 5. And then 1 times 5 is going to give us 5. So 1/3 is equivalent to 5/15. Now what we are actually adding is 6/15, add 5/15. We can ignore the denominators and just add 6 and 5. And my number bonds tell me that that is going to be 11. So my answer is going to be 11/15. Like that for you. 11/15. Okay, happy so far with different denominators? Right, so far we've just been revising what we've done so far, calculating with fractions. What if you've got 2 mixed numbers? So what if I had 1 and 3/5 add 2 and 1/10, like that. So luckily I've got 2 mixed numbers, so they are the same type of fraction, but we've still got the same problem of we've got 2 different denominators. Now, do we need to find a lowest common multiple of 5 and 10, or have we already got one given to us? That's right. We can simply convert fifths into tenths, so we can keep 2 and 1/10 as the same. We just need to convert our 1 and 3/5. So my 1 stays the same, I've still got 1 whole, but my 3/5 we need to convert into tenths. So we need to convert 3/5 into tenths. Now 5 times what is 10? And it is 2. So we need to do the same for our numerator. So 3 times 2, which is going to give us 6/10. Now what we're adding is 1 and 6/10 and 2 and 1/10. And when we're doing mixed numbers, you can add the wholes like normal. So 2 add 1 is going to give us 3. And then add the fractions. So do the whole numbers first and then add or take away the fractions. So I've got 6/10, add 1/10. So I'm going to get 7. 3 and 7/10 is going to be my answer. Okay, still easy. All the same skills. You've just got to think, I need the denominators to be the same to do anything with them, okay? The last one. What if I've got 3 and 2/3, take away 1 and 5/6, okay? So, again, they're already mixed numbers, but we've got the different denominators again. So again, do we need to work out a lowest common multiple, or is one already given to us? And we know that with thirds we can convert into sixths. So my 1 and 5/6 can stay the same. Don't need to do anything with that. I just need to convert the 3 and 2/3, sorry. So it's still 3 wholes, but 2/3. What's 2/3 going to be in sixths? So in my head, I'm going to think 3 times 2 is 6. So I'm just thinking in my head, instead of having to draw my arrows, which you should all be more confident with now because we've done a lot of converting. So as I said, 3 times 2 is 6. 2 times 2 is 4. So 2/3 is the same as 4/6. Now, what I can see here, now that I've converted my 2/3, I've got 4/6 take away 5/6. Now that is going to be a little bit tricky, so we are going to actually convert these yet again. This time we're going to put them into improper fractions. Remember when we convert from mixed number to improper fractions? So if I've got 3 and 4/6, I've got 3 times 6, which is 18, add my 4 that are left over, 19, 20, 21, 22. So I've actually got 22 sixths like this, and I'm taking away. Now my 1 and 5 sixths, I've got one whole, so 1 times 6 is 6, add the 5 that's left over, 7, 8, 9, 10, 11. So what I'm actually doing, and these are equivalent, remember, but 4 6 take away 5 6 we can't do because there's not enough, and we'd be breaking the whole. So using improper fractions is a lot easier to see how many sixths we've got left. So if I've got 22 sixths, take away 11 sixths, I'm doing 22 take away 11, which I know is going to leave me with 11. Now we can put that improper fraction back into a mixed number for our answer. And so I know I can get one group of 6 with 5 sixths left over, like that. Okay? Now, on your code breaker today, their answers are all at the top and they represent a letter to spell out the code. So if you are struggling, try and use process of elimination to work out what the answer could be. If you're close, you might need to calculate the answer again, or as I said, look at all the answers available and see if you can work out the right one. There's level 1, which is easy, just to give you a bit more practice of all the calculating we've done with fractions, or there is level 2 if you really want to challenge yourself. The answers will be posted tomorrow. Best of luck, agents.